Live streaming is on.
Great. Okay, we're off for 1 hour. How do you want to do this?
Yeah, so I read the request. There's more in there than I expected, but I guess I did kind of expect that too.
What parts were surprising?
Oh, it's nothing really, actually, to be honest. I think it's fine. Like I might have shot down a bit of a weird path, like just looking at ORMs that are around in Node right now, and
Was it misleading to call it an ORM? Is it still an ORM?
I don't think so, because like as I've been thinking about this, like it actually fits pretty cleanly under that concept, because like I started trying to motivate why you would want to write an ORM layer, and what I realized is like I would say the number one feature you're trying to achieve here is just like nesting, right? Like objects that have other objects inside of them, and how does that interact with like ejection out into the IPFS layer and like pulling back in from the IPFS layer, right?
That is probably the primary purpose. Yeah.
Yeah. So it's literally the same as an ORM for a database. It's like I need something to manage. I need something to manage the joins, right?
It seems different because in a traditional ORM, you never care about diffing or deduplication of the members of your object.
Right. And that's an extra wrinkle in this context that I think is really important, right?
That's the primary reason why this is becomes unmanageable without this layer. Like this layer just deals with that for you because storage matters in a big way. And it slows everything down horrifically if you're using content addressable stuff that's not leveraging the deduplicatable nature of the medium you're working in.
Right. So what I want to say is like basically like the key word in my opinion in ORM is relationship, right? Like you have marshalling and unmarshalling data from a database in a traditional ORM. Like basically that layer is there to hide like the IDs that you're using to link things together, more or less, right?
Correct. Yes, and in that sense, this is identical to that, hiding joins, like you said.
Yeah, and I was surprised the more I thought about it. The comparison really bears out quite a bit. Like, you know, when you're like exploding something into component pieces, like what's the reason you would add a join to a database table is usually because there's different amounts of churn in different parts of the data system.
Yeah, right. And you might want to reuse parts of a table when you're dealing with a different group of relationships.
Yeah, and not only that, there's different political interests in different parts of the database. You might want to shard parts of it off into a different subsystem somewhere. Like the comparison actually really tracks, in my opinion.
Cool.
And so it shot me down this path of like looking at how ORMs are built in Node right now. And I don't necessarily like the one thing that surprised me, I would say about the request is just at the beginning, like it's talking about either using a tree of like class instances that kind of normalize those links, or it's talking about possibly having a centralized factory type method. And I would say the vast majority of ORMs that exist that I surveyed use the centralized factory method.
Yeah, I think it might have added an extra complication for me. And now that I have the complete system limping along, at least I'm using it the way that I want to use the permanent system, and I really only use it at the pulse layer. It's like pulse, crush, pulse, uncrush, The interpulse notion is sort of, again, it's not random when I want to call hydrate or dehydrate.
Right.
It's not in any location at any point in time. It's at very defined events where I have system context available. Like I'm not just running a random function and then I want to call it. The only exception to that is the hash array map try, where like I want to rehydrate a piece of it. I may be able to acquire the system context and provide the resolver at that point in time. The way I've been handling it right now is to bury the resolver in the object so that it was just there when you asked. Yeah, it's sloppy. Very convenient, but sloppy. Yeah.
Right. So, like, to me, I want to kind of switch over to talking about what I think is probably the best ORM right now, which is Prisma.
Yep.
And just like the modeling language on Prisma.
Yep.
I think what I kind of got when I read your request here is that, like, in the modeling language of Prisma, basically you're using these directives, these at handles beside the properties in order to in order to grant extra capabilities at that key. So
like there's an annotation language that they parse on top of it, right? Like, and it sort of looks like comments.
Yeah. And it's really smooth to work with when you do it that way, because it basically means the annotation language, it's almost like mix-ins, right? Like it's like you inject these things in the side after, and they have to be predefined, and like you can grant them kind of anywhere that you want to in the model. I don't know if this is like kind of overdoing what you're thinking, but when I read your comment for like hash array map try, like the data structure to me like is obviously important here, but it doesn't matter as much as the property that it's granting, which is like the quick lookup property, basically, right?
And the quick write.
Right. And so like you can kind of start to, if you use an annotation language like that, like you think more in terms of like, what are the properties I'm granting here, rather than like, how am I granting them, right? So it's a little bit more denotative than like operational, I guess. Now, the thing is, like, if you're only going to use this in one place, I think defining a language on top of it, like to specify how these models work, is overkill.
Definitely smells like too much.
Yeah. But like, what I wonder is if you can't like come up with like a little JSON spec that doesn't, that takes inspiration from those guys, but doesn't require writing a parser. Or like at least not a parser that has to read strings anyway, like a parser that just looks at properties and understands how to like attach the code the way that you want there. I would, okay, what I'm trying to say is I'm in favor of the centralized factory version of the ORM.
Like the central, okay. And you, more specifically, you would like the centralized factory with annotations of some kind.
Right. Yeah. Like with decorators, basically, right? So
decorators, yeah, I love a good decorator.
Now, we want to avoid decorators in JS right now because it's a never-ending spec. Like it like they're never going to settle on anything. But I almost wonder if we can't just have like a little array of annotations for a property that says, say, this is crushable, or this requires a model check on hydration, or this requires a model check on dehydration, or this needs to have quick lookups or something like that, right?
Yeah, I think get what you're saying. So basically, the way that you'd want the developer interface to go, the way that as a consumer of this library, I would tell you the behaviors I want out of these systems would be primarily through annotations.
It's more denotative, right? Like it's more functional, I guess. It's less like you're not going to mix up the how and the what, basically, if you do it that way.
So you're saying that also that your preference is not to have a class inheritance that I need to extend in my classes. It's much more, there is no base class for an ORM class.
It's a personal style thing though, right? That's why I think we need to kind of talk it through. Like I'm much worse at like an object inheritance style system because like I constantly get myself caught in the like banana gorilla jungle problem, where like I don't know what level of baseness is like the right place to implement this. And like I also don't really know what baggage I'm carrying around with me in any given like point in the inheritance tree. Like I've always kind of preferred the mix in decorator style, basically.
Because you don't like inheritance.
It breaks orthogonalization, right? Like if you're going to grant extra properties to a method, like
Okay. The reason why well, for example, often throughout the models, I need to get the hash of that particular piece of data. Using
Right.
the annotation scheme, how would I access the hash of an arbitrary piece of data?
um, the purpose of like building a nested kind of centralized modeling language is to like use the hashes only under the hood. What's the intent of having the hash? Like how do you use it when you have it?
Sometimes I do a comparison where I go, this thing and this thing, is it hash equal?
Right.
Other times I want to store the hash of a thing because I need to stop the hydration because the blockchains, if you just were given a pulse and you hydrated everything that was a hash, you would hydrate the entire chain and worse, all the chains that sent actions into it. And so
Right.
there are places where I need to signal that's a hydration boundary. Do not hydrate any further. Show me the remainder, just the hash. Leave it as the hash.
Okay. Yeah. So I mean, to me, that what you're saying is basically it's important to be able to mix up like the how and the what a little bit, just for
You
the
have
purpose
to,
of optimization.
or else you inflate forever.
Right.
And sometimes you also want to, like for the binary layer, you never want to inflate that, but you do want it available to you. The biggest conundrum appears to be when the developer asks for a pulse. What do you give them? Do you give them an ORM inflated object? And if it has the hash array map trie in it, how should they rehydrate the pieces that they need?
So yeah, like you're going to run into a problem where they're not thinking about the semantics of like the chain, and they're going to ask for way too much shit, basically, right?
Well, or you've now passed a hydrator function into devland, which could be exploited. Now you need to consider that the hydrator has to be aware of what this caller is allowed to hydrate.
Right. So it's important to make sure that this is only applied on system level functions, basically.
Yeah.
Right?
Now there's one way that we could attack that problem is to make it so that in userland you cannot access an ORM back. You cannot access a pulse.
Right.
You can only access things about a pulse, like what is its hash, how many channels. You can ask some questions that may prove useful, but in general, it seems like in userland you only really want the state and the binary. You sort of have no business digging into the system level properties of the blockchain.
So yeah, I mean, I think we've talked about this before. To me, like when you talk about that, it's reflection, which is like half the developers think reflection is great, the other half think it's
evil.
a nightmare.
I think it is a narcissistic, stuck-up thing to put into a language. It is a non-utility function. Like, get out of I should never, I never want to see the inside of the language, right?
There's one case where I think it's important to really be thoughtful and considerate about whether it's a good idea, in my opinion, which is, do you anticipate, like, instead of me looking at my own blocks, do you think, or pulses, I guess, I'm sorry, I'm trying to retune my brain here.
Yeah.
Is someone else able to look at my pulses? Like, can I build a supervisor tree, basically? Can I build a liveness layer on top of my objects that like allow me to make statements about the behavior of the system?
Absolutely. Caveat. So, for example, there should be no reason why you would need to delve into the current state of the active channels of the chain for any reason, because those are completely dynamic and they're sort of not your business. But would you want to delve into the history of this other chain? Yeah. Would you want to delve into the state of it? Yeah. But
are the actions actually like in the pulse when the pulse gets committed?
The actions that were received from another chain.
Mm-hmm.
This is that. Technically, yes, but also no, because they came in as a result of a hashed transmission from another pulse. So they were never rehashed. There was just reference to the hash that.
So their hashes are inside the pulse boundary.
Yeah, so you can rehydrate them, but they are not rehashed or recreated. It's the initial hash from the sending chain that is just reused, because why store the data twice?
Right. Yeah. No, I mean, that makes perfect sense to me. It's not really your data when you're receiving it from another chain, right?
Yeah.
It's technically theirs.
Yeah, the idea is that the engine would check that it can hydrate everything that is referenced by hash in that incoming interpulse. But it doesn't. It just treats them like another piece of hash data.
Okay. So there's one exception here, which is you have to save your outbound, basically.
Yeah, and so the way that's done is I made a special slice at the base of the chain in the provenance, which is called transmissions.
Mm-hmm.
And then transmissions has all the active sends that are currently occurring all there. And then transmissions is blanked next pulse cycle.
Right.
And
and they're there like in a hard sense, or they're there by hash?
They are there by hash.
Okay.
Because they share the duplication of the channel being stored in the network hash array map trie, and they are simply the hashes referenced from this exposed key that is used by the engine to transmit to the appropriate other chains. And then when the other chain receives it, the idea is that the permissions model would allow them to look into just the transmission slice, just the validators, and the signatures, just enough of the block that is of concern to them, and then and that's all they can see. Those are the only hashes that they need.
Right. Okay. Yeah.
Can I talk about a conceptual point that will influence this design significantly?
Yep.
That is the topic of, should we disallow the use of hashed data within the state of a chain? And my current argument is yes, we should, because the correct way to reference hash data from the state of a chain is to reference a child.
Okay.
Now that means that you're wrapping that piece of data with this management sphere, which is a chain, a pulse
Mhm.
in our system. But it seems to be mixing purposes if we allow you to have CID linked data inside a state.
Right.
Because
So
why are you
no,
doing that?
I'm with you. I'm with you 100%. It's like the only reason to use any kind of ejection and hashing into IPFS is to support getting fully into chainland as quickly as possible, right?
Yeah,
And the only people that should do it is the system.
yeah,
The only like chunk that should do it is the system, right?
yep. Okay, so we're in agreement there, and that means that this ORM is not for inside chainland.
Mm-hmm.
Now, what we may find is that your idea about annotations of some sort might be extensible to support. It would be object chain mapping,
Mm-hmm.
where now you can instantiate objects that represent and are backed by a full-blown chain.
Yeah.
And then that chain is underneath is all the hashing and the IPFS stuff. But here it's our world, it's Interpol's world, and that's how you handle your things. And so when I'm writing a reducer, I can refer to this whole other chain by this object that was reinstantiated using our library, and I can work with it in a very natural way. Now, part of that is already done insofar as the API of a covenant is specified in JSON, which makes it interrogatable by another object. So for the Interpulse object, it has these shell commands. The shell is imported and interrogated to work out what is the shape of the functions that need to be called. When a developer calls the function, all it does is make an object that matches the shape specified in the API and sends that to the running chain.
Right.
And so in that sense, you could give the developer an object that represented a remote chain, and all they got to do is async await the functions that they call. Our layer transitions their function call into an action, to an interchain action that then has a response and then comes back. So that's pretty, pretty doable, and it might be able to be done in the same style of interface as what you're contemplating here.
Yeah. Have you worked with Prisma?
I reviewed it when you suggested to, so I played with it and looked at how it worked.
Right. It's, I think there's a lot more to it than we need to specify anything, even in this land or in chain land, right? Like, but like I really, it's just a feeling to me more than anything. Like I can't back it up with like a ton of reasonable logic, but the idea that like annotating, and I guess the other thing here is like it's not necessarily true that it's only keys that we care about, right? Like you have this CID links and class map in here, which is basically decorating keys inside this object, right?
That is exactly what I'm doing. I am decorating keys in a bastardized, slapdash, haphazard way.
Right, but like you also have all this logic down here in the actual interface methods, and just kind of off the cuff, looking at the way you've done the classes here, like it does seem like co-locating those two things is a little bit more flexible when you're building stuff out like this. Like basically saying, here's my decoration part, here's the logic that I'm throwing in here. Some of it is specious, it's individual to this class. Yeah. Some of it is just implementing generics, right?
I want to completely pull out the generics part. That's the part I want libraryized. And I want the rest to just be my pure classes. Now, I love classes. Do we have common ground on that, or you prefer not classes?
I'm happy to work with whatever. I will tell you that, like, for some reason, it never worked in my brain. Like, classes always induced me to like focus on the complicated solution instead of the simple one.
Right. Yeah, that's true. The reason why I really like classes in JavaScript is private fields.
Yeah.
That's pretty much, that's all. That's the thing I want.
Right. So I think this is a two pass task, basically, right? The first would be like, let me figure out what are the generic methods, like what are the ones that are on all sorts of different instances here, right?
Yeah.
And pull those out into like yet another class, basically, that can be instantiated, right? Or sorry, not instantiated. Extended, I guess.
Yeah,
Inherited from.
Right.
And then the second pass would be to consider whether. So if you add a modeling language on top of this, basically what you're saying is, I still can't see enough of the salient details of the objects right now. Like, there's still too much stuff on the screen that's blocking my view of like, oh, this is nothing but an array over here and an object over there and this type of data field over there, right? If you want to add a model language on top of it, it's basically so that you can have a much more clear view of like, what is the data composition of this object.
Yeah, but then see, we've also got IPLD schemas, which was it was powerful to be able to go through and try and spec the first pass of the system in schema. Now, it would be, those guys have done a lot of work and their systems are deployed in a lot of places, and so being able to connect with that, right? And the idea was that in the during the hydration and dehydration, I wanted to optionally do a schema check in IPLD schema to make sure that is my data conformant to the shape that I expect, which allows me to be a little more sloppy in JavaScript land. Because sorry?
Which is what the purpose of the model language is. So
yeah,
the IPLD schema here kind of is the model language, right?
Right. Yeah, right. Okay. And so what you'd be talking about is inserting some annotations that directly can be translated to IPLD schemas.
Or maybe there's like a superset of the IPLD schema where like you can toss extra annotations on individual fields. Like I noticed down here, as an example, like let's take DMZ. You have a field config on DMZ. You have a type language on top of the field config. You're saying what type of data is occurring at each field on this object. Like you can also have some kind of like property key that like it's like a 2-pass read now from the IPLD schema. The first pass would be like pull out the properties that decorate the fields. And then the second pass would be dump the schema into the class that you've just instantiated. And then like listen to the properties to determine whether I should crush or uncrush this, or sorry, whether this is a crushable field basically, or whether this is a type checked field that should use the IPLD language. Again, it might I don't want to mix things up here either though, right?
Yeah, that's the danger, right? And then we've gone from like this sort of this dirty little thing that just worked for my purpose to something that is large and might not work for my purpose, right? Like that's the worst the worst path we could go down is like
are the IPLD models here, I'm going to keep calling them models, schemas, are the IPLD schemas here one-to-one with the classes?
They are supposed to be, and they are currently held manually in line. Now, from the IPLD schemas, I have auto-generated a schema checker because that's part of the tooling that they provide. I have not yet inserted that in the classes, but the place to do that is in the crush and uncrush functions. I could simply call on that JavaScript file that was generated in W6 schemas and check the actual data shape and know that it matches the schema I wrote in IPLD schemas.md. Okay. So I can actually do that.
It sort of strikes me that I want, one way or another, I kind of want this stuff to be co-located. Like I want the IPLD schema right beside the like extra declarations that I'm making about specific fields, right next to the specific instance logic that the class that I'm using here is going to have. Like I want that to be a tuple, basically, right? They don't have to be glued together in a new structure. They can just be like one file would have my IPLD schema, which keys are being decorated with what, and then the actual like class itself.
Okay, so why don't we just use JavaScript decorators?
We can, but like I said, there's a lot of churn on that spec. I'm really, really, really nervous about it.
I don't think the churn's really going to hurt us much because the reason we're using it is like to co-locate the decorations on top of the fields in the classes that the developer supplies. And that is a very simple use case. If the spec changes, we can change too. Like,
right.
The only complication is our annotations supported by the tooling that we use. Is it, like, does it need a compiler?
I'm not going to write a compiler. I'm not going to write an AST walker. I'm not going to. I don't think it's worth it. I think
No, I didn't mean that. I meant like, if I want to run this in Chrome latest, do I need to transpile the decorators out?
Yeah. So decorators are like, they're not a finalized spec, right? Let me see if I can get to the ECMAScript proposals GitHub.
Yeah, here we go. Fun times. Can I use? It's a whole lot of red there.
So decorators are like the last stage before finalization, but they also have been since
back in the day.
Yeah, like since React was first released, basically. So, like again, I don't see any reason why we need to. You get what I mean when I say tuple? Like, let's put the specific class logic as a class file, as an export in the same file as the IPLD schema, in the same file as the keys that are like CID links, the crushed keys, basically. And like, they're just modules, right? They're just exports from a module. They don't have to be mixed together with any sort of special like language tools, right?
Yeah, the language tools sounds hard.
Mm-hmm.
Like decorators.
It's not worth it. It's not worth it, in my opinion.
Okay. All right. Well, the reason I like this packet is that it's a rare opportunity to be able to provide a new feature to the core, which is encryption. It's a vital feature because IPFS provides no encryption at rest by default.
Right.
And so if this ORM was pulled out of the current code base, even if it was in a crappy version now, it would still allow the insertion of a new core feature that's, in my opinion, vital to be added without any further complications to the core. And I like that.
Yeah, I agree 100%.
So the way I thought that this process would go in the Dreamcatcher is I write the request, you write the idea, we bounce back and forth. You ask me, do you really need that? Or did you mean this? Or, should it be this? You come up with the idea and I'm like, that sounds too much, or that doesn't do this other thing, or I need to modify my request. We converge on a pairing of request idea. It may be staged, like the request is here and you're like, stage 1, this idea. Then later we'll move to, so that it sort of doesn't have to be done all at once. And then we talk together about what the funding needs to look like for that, because that's sort of until we have spec'd it concisely, there's no hope of getting the funding right. So but that's where I want to get to, is like, here's the funding, here's the packet, and then there's actual real money from our funder is put in to our incorporated company, and it's sitting there waiting for this packet to be delivered. That's where I want to get to.
Yeah, I agree. I haven't got very far in the idea yet. I said I would be done, but
It's cool. It kind of goes like that, like I've been listening to a talk by Leslie Lamport, and he's saying, like, look, there's a trap that happens in your brain that makes you think you know what you're doing, but until you actually write it down, you don't know. And so, like, if you're like, yeah, I'll have it done for sure, because you think it's clear, and then you go to write it and you're like, it's not that clear. Perfectly normal.
Right. So what I'd really like to do is I'd like to make the case for the absolute far future, like perfectly ideal version of an ORM here, where like everything's as separated out as it can possibly be, where upstream churn could be tolerated, where new features, like new ways of interacting with like the blocks that you're storing on IPFS can be added over time, where everything is just kind of orthogonal to each other, right? And I think that involves a model language, but I also do not want to write a model language. I do not want to like go to weird esoteric language features. What I want to do is I want to like look at the point I would ideally tether to, and then figure out like what's the closest I can get to that in like a short chunk of time that adds value.
Yeah. Like, here's what you want. And then what I think we should spend some time figuring out is this actually useful to someone else? Like, because there's two drivers for why to libraryize this. The first one is for the sanity of the core. The second one is for the utility of others. Now, from what you and I just spoke about, maybe sounds very heavy on the utility to others part is where you're coming from. How do you gauge that?
It's not though, right? Because like when I started writing this down and I realized how close this reasoning is to like database schema design,
Yeah.
And I realized like we're guaranteed not going to get the right schema the first time, right?
Guaranteed. Every time. And yet you're not going to get the right schema without the wrong one first. So
So what you really want is something that allows you to like flex the schema in a way that everyone can be like, that's the right idea. Like that's the right addition right now.
Right.
Like in order to address the problem that we're talking about. And so like that's the toolkit we need to build in an ORM. Like you'll get encryption at rest for free with it, right?
Yeah.
But like it's the change management that's the most important part of an ORM, right?
That's right. And the ability to look at the code base that we've written and understand rapidly what I mean when I have like a class with this piece is a CID link, this piece is not, and then making a modification to the core model and not getting screwed for it. So versioning, migrations, the other fun parts of an ORM that people hate, but yeah.
And I think like it'll be I don't want to attack any of those problems until we have like kind of I think the MVP here is basically what are the methods that go with the interface and what are the methods that go with the inheritors.
You mean what are the methods that go on the central thing?
On the base class. On the base class.
And, okay.
Unless you're thinking there needs to be more than one base class, like there's a zoo of creatures here.
Well, I thought that there would need to be at least two. One would be like this is the general purpose, how you do stuff, and then a second one would be for when you want to represent hashes directly. Like for example, an address. I've used a content ID version 0 to mean an address, and content ID version 1 represents pulses. It worked out great because I can, at a glance, be like, oh, that's an address, or nope, that's a pulse. That's been useful. But, I need to be able to represent those primitive objects in the class system. But if I inherited from this base class, then it's not quite so right. And then the other thing is, like, the hash array map try would need to be a dedicated class that we provide, because that's not the same as everything else.
Yeah, it's still kind of, you'd want it to present on, in my opinion, you want it to present on a common interface to every other model type, right? Like it should be an implementation detail that it can do efficient lookups and like writes, basically.
Well, the trouble is that it changes your function call to have an async signature.
Right.
That's a big change.
And everything else in these classes is synchronous, right?
Yeah. You're right, though, that you could make it be a decoration that just says hash array map try, and then you're like, well, we know how to process that. And
there's lots of things we could do. I think probably some of them will end up being way harder than it seemed. And
yeah, right, because that's an example of, like, who would need that. We don't need that now. Someone else might need it, maybe, but that's a lot of work.
I also think that, like, there's probably going to be more than one place in the final schema that we end up building where you need certain types of guarantees in your, like, objects, basically, right?
Yeah. So there's an assert logic hook that I put in the classes as well, which is like, it's not enough to just have your data type checked. It needs to also make logical sense together as well. Like, when you get a block back, a pulse back, sorry, is it valid? Like, just because you've got some signatures, do the signatures match to the public keys correctly? That's a logic check, not a type check. And so there's a hook in those classes. I just called it assert logic. And if the object has that function, run that function, and that's the developer supplied consistency check.
Right. Yeah, I'm starting to get a sense of why this is a hard conversation, is because you're kind of managing up and managing down at the same time here. Like, you're managing your relationship to the underlying data layer, IPFS.
Yep.
And you're managing your, like, relationship to chainland stuff too, right? So, like, in the chain world, would this make sense? I think anytime I see stuff like that, I think it needs to be kind of just separated from each other a little bit. That's all.
Like how?
Like how? So I think, like, there's one generic class in here which is basically only providing the tools to, like, correctly push this stuff into the database or into IPFS, I guess, right?
Yeah.
And then, like, your logic class would be another type of class. You can.
The logic class, that's how it is right now. Like, there's the base class is how you go in and out of IPFS. And then on the way in and out, when it's rehydrating your logic class, it tells your logic class basically, hey, you've just been reinstantiated. Would you like to check yourself?
Right. Well, it sounds like it's actually pretty close to the thing it needs to be already, hey?
I think so. I just wanted to hear some alternate ideas to it, because I approached it. I came at it piecemeal, little bits at a time, right? Now I'm like, oh, that's a thing that's always going to be there.
Yeah.
Should it have been designed like that? Maybe, maybe not. What's the alternative?
You can't. I mean, like, you're talking, like, code is always made bottom up, right?
Yeah.
Like, The top down part is always like a post facto rationalization.
Yeah,
right?
yeah. So now we're at the top down bit, and we're like, well, what's it going to be? And I still question the utility to other people. It's definitely not useful to inside chain land, in my opinion.
No, we wouldn't want to make it that way. Like the extent of the features in a layer like this is basically like providing for things that need some degree of centralization, like uniform encryption.
Yeah, that needs
and
to
then-
be yeah,
and then like
I'm sorry.
and then the bare minimum that we need for long-term change management, assuming we haven't properly built the right schema here, right?
Which we haven't.
Right. So, I think those are two relatively hard problems that I'm going to actually need to grind gears a little bit on, right? Like,
what is the harm in just doing a really crappy extraction first?
yeah, that's what I think should happen.
Okay, so we'll try and do. So you're saying that phase one would be just a pure extraction of the code out of the current code base, and then refactoring the current W8 folder to use the new libraryized ORM.
Yeah.
And then regroup from there.
Right. So you already have IPLD interface, which is your root object, right? Or your base object.
Yeah. And I apologize in advance that I haven't normalized what should be in IPLD struct versus IPLD interface.
Well, can you help me understand the difference between the two?
Sure. Interface is inherited by the binary class, the address class, and the pulse link class. Also, I think the state class. So anything that needs to do its own sort of custom interaction with the IPLD system must inherit from IPLD interface. But IPLD struct is what you do when you want to have an object with fields.
Okay. That makes sense. So there's a few things that need to be a like lower level interop with IPLD.
Yeah.
And then there's a few that need higher level interop.
Yeah.
Okay.
So pulse link is the sort of the main. Pulse link is the main concept that it basically the end of the hydration is an important concept. There's another special case in the interpulse class. The interpulse class inherits from nothing in the ORM. It's basically provided with an already hydrated pulse, and it simply is a view on the pulse. Now, I just went and did it, and it kind of works. But you can see that the message signature provided sort of overlaps with the IPLD interface, but I couldn't quite get them to match because they're not the same. Like, you would never crush an interpulse. You would never, strictly speaking, uncrush it either, and yet it has a CID because the pulse has a CID. Yeah.
I can see the type signatures, like the schema is written in comments, like in Markdown comments in the.
I manually copied that across from the Markdown doc where I wrote them all. The schema generator, if you run yarn schemas, it will read the Markdown doc and generate automatically a schema validator for you based on the Markdown doc. So there is some level of bastardized automation there, but I really wanted to be uniform, but it's like the price and the utility. Who else really would be making this type of thing, right? I haven't bumped into them. Right? And you tend to do that when you're on the internet making these things, checking issues and looking for help. You tend to bump into people who look like they're doing a similar thing. I didn't see them. What does that say? Maybe nothing. But what I think it does say is that we need to find out more about the utility of this ORM to anyone but us before we do anything that costs money that isn't of direct benefit to us and is of direct benefit to others.
Right. Yeah, I mean, it probably won't have any more utility to anyone that's not in the core project, right?
Okay, well, that sounds like a good objective for phase one, right? No external utility considerations. So, like, if we just libraryize it and then look at the utility after,
Yeah, I think that's the right call. It's just maybe not even a library. Like maybe you're just turning it into something that's like inherited from everything else.
well,
like maybe it's just another class in here.
I wanted it as like another package in the mono repo.
Okay.
Because just only because of if it isn't, it becomes tempting to reach into it and fiddle around with it.
I know exactly what you're talking about.
And
I've watched it happen over and over again. It's like
and
you have to put a boundary around things, otherwise people just don't respect it.
No, right? And there's only us two right now, but we want there to be more, and so that boundary is pretty critical.
Okay.
And then another thing that I'm not proud of was that I did the tests on this ORM by testing the actual model classes themselves as I built them. So there's no like explicit and genericized tests upon the ORM. If this was its own independent library, it would be tested independently, and so it would function better and have less edge cases and less errors because I just patched it.
Right. Yeah. So I'm really racking my brain right now trying to figure out anything else I can about like alternative ways to implement the feature set you're talking about. It's occurred to me that like GraphQL is another example, I guess, of like kind of how you would map out objects and build a handling layer on top of them.
Yeah, that's quite nice. Well, why don't we talk about how we should at some point make a GraphQL-like query language to be able to go across chains.
Sure.
Now, maybe that is the same thing because GraphQL, you do your queries in their their funny language, right? Like with the backtick, and you've got GraphQL backtick, blah blah blah.
Yeah.
Now, we could do that, but using
it's definitely a layer on top. Like there's some core semantics to figure out before it's useful, I think.
We need to pick a query language because you don't want to query chains. You don't want the whole chain in RAM. You want to actually do some processing and pull some bits out.
Right.
And you want to be able to search for conditionals like field greater than this or that, and you want to get back different shapes than what the chain shape is, because like MongoDB is great, but it doesn't let you do that shape shifting thing that GraphQL does. Like that's a really useful thing.
Yeah, it's a pretty big game changer. I mean, it's what we've been writing on, and I guess I was kind of thinking of it a little bit deeper down than like how you start building whole apps on top of it. I was just thinking that like beyond the type declaration, like basically in the type language, you would again have the ability to declare mutations and queries and stuff for all the types that you're declaring. So it's almost kind of like building an object. It's just it's just that the actual functions are kind of declared separately from the data types, right? And when you go to implement it, like basically you implement it through resolvers, and resolvers are like functions that like automatically spin up based on your declaration of queries and mutations, right? And they would be like everything would be type checked and fed in. And so again, the actual implementation is somewhere else. So you kind of have like data over here, like interface methods over there, and actual implementation in a third place. And like I found that to be very good for not getting things mixed up as we've been working with it,
Okay.
Like first of all, having a really clear like type, like model kind of language makes it really clear what the actual data composition of everything you're looking at is, right?
Right. So in developer land, they would have to specify all that typeness.
Yep.
Is it correct to say that there might well be no overlap between the model system we use to build the chains and the model system used inside developer land to view the chains?
I don't think that's necessarily true. I think it's likely. I think like if you really zoom out and squint, like making a child chain is basically making an incredibly elaborate system of pieces that will be written independently into IPFS in order to guard that like little blob of state. So
hold on just a second.
Mm-hmm.
With merely a modification to the resolver function, so where did I put it? The IPFS interface, right? It's just put block get CID.
Yep.
If we modify that slightly, it should make no difference whether you're using IPFS raw or using one of our chains and the network of child chains to fulfill your puts and your gets.
Mm-hmm.
Right?
What would the modification be?
Well, you'd go when you go put block, it's going to, instead of having a CID, it's going to have a reference to a child chain address, and then it's going to do update state on that child chain, as opposed to just storing the block in IPFS.
Right.
And when you go get CID, it's going to be get by chain ID, and it's going to go fetch the latest from that chain ID and then return it back up. Right. So I guess get would also need an app root reference where you're like, relative to this app root, give me this chain ID.
Do you need a app root for that?
Yeah, because otherwise you'll get different results depending on when you asked your question.
Right.
But what I'm getting at is that the developers in developer land could use the same the ORM for being backed by chains and being backed by IPFS blocks could be the same just by switching out the resolver functions.
Yep. Yeah, it's like the same front end with different back ends, right?
Yeah.
And the back end of put in Chainland is basically asking the network of validators to do it for you,
Yeah.
whereas the back end of put in Blockland is like put it in the block basically and put it on IPFS.
No, it's still got some processes. Like it's put it in the local database, broadcast it out to my peers, insert it in the find where it belongs in the distributed hash table, make the connections to those nodes and insert it. And then if you're in the browser, call the preload servers because you don't have the ability to, you're probably going to disappear. So there's a whole lot of stuff that happens for that put call anyway.
Right.
And if we're just backing put with chains, what's really the difference from the ORM's point of view? It's like, do some shit that takes I don't know how long and get back to me when you're done.
Live streaming is on.
It's sort of the difference between like, what am I trying to say? If you write to your program's memory, you're not thinking about like all the shit the operating system has to do to like move that around and give it like triple pointers and so that it can like optimize RAM every once in a while. And,
Yeah.
But it is still fundamentally kind of the same interface, right? But like
Yeah.
at the same time, you're not usually thinking about memory at all as a programmer either, right? Like,
no, you hate thinking about memory. I think it sucks. You want to think about it like it goes forever and it's instantly available, and that's the model.
Right. So like it might be a bit premature to say that we're going to build an. I mean, I guess the thing is like your program will still need to put and get things, but like we want to. I guess the point is put and get here are kind of like hidden from whoever the consumer of the ORM is, right? Like you should never really think about them.
Yeah, they're built by the system. They're built by a different level to what like from me building the Pulse models, I want to just completely ignore how it all gets stored and hashed and all that. And I just want to think about the logic of these pieces and how they all fit together and interact. That's what I want. And then when I'm in a chain, I want to think about other chains as objects with functions that I can call on and I can read the state of. And I don't really want to, I don't want to do much more than that, really.
Yeah. So I think like what I just want to warn is that like we're bumping into the same thing where if put and get are completely interface compatible between chainland and hostland,
Yeah.
then we're back in the zone of like trying to make the host into a blockchain. It does kind of beg the question of like what if you were to just use the put and get versions from chainland and run the IPFS level code.
You should be able to do that just fine.
Right. And I think like the fact that like it's very clear that could happen now versus in the past means that the design is better, right?
I think so. I think because we separated out the hash layer and said that hashing is layer independent. It is the one thing that is common to all layers, no matter how nested you are.
Mm-hmm. I think that like it means you could switch on hyperconvergence. If you wrote the ORM the right way, you could switch on hyperconvergence instantly.
Yeah.
I'm not sure. Yeah. I'm not sure if you want to, but like
that's one of our principal design checks, though.
Yeah,
hyperconvergence means we built it right.
Right. Okay. Well, I don't like. I think it's probably beyond the immediate task of the ORM here.
Well, it's nice to if it's got a plan for future utility.
Yeah.
Then that makes it of more usefulness than just scratching an itch right now and maybe never being used by anyone else. If we're also going to present it as the developer experience tooling, that makes it significantly more important.
Right, but we should also like tiptoe into it, right? Like I think it doesn't make sense to write a fully parsed model language or like say adhere to GraphQL if that's what we want to use as our model language without writing like whatever its compile target would be, like the AST of like the AST of like how am I properly thinking about this object, you know?
We should definitely sugar it last.
Mm-hmm.
It's a shame the annotations aren't there yet.
I think, like, to me, that's my favorite part of GraphQL is the fact that you can just stick this little @ symbol and like run extra functions on any key, and like it'll just do extra cool things to them. You know, like it'll do a permission check before it loads this sub object into the object, or you know, it'll go through the cache first instead of going straight to the database.
Is there a way to use the GraphQL library to
Like
specify?
Honestly, the resolvers do whatever you want, right? Like, I could write all of these IPLD like specs in GraphQL and then just use the resolvers to actually do the thing. The problem then is you have to come up with a piece that gives the machine a whack and like actually feeds the data through, I guess, you know, like that means you're asking for everyone on the outside to consume the thing using GraphQL queries and mutations, which is arguably like a little bit of a pain in the ass right now. I think it's a little heavy.
Okay,
it'd be cool.
So a wild idea. Then we could ditch the IPLD schemas because we actually, if we can take GraphQL schema and we can check that it maps correctly to an IPLD schema, that's all that anyone needs to concern themselves with.
Yeah.
IPLD schemas are a lower level again. And if we can avoid developers having to worry about that, that's great because they are actually language independent schemas. So it sort of loses a lot of punch, but is also more powerful at the same time, but it is awkward.
It's not only that. Look, I can, if you write the GraphQL schema in the right way, you can actually, every single time it gets invoked, you can walk the GraphQL type schema and convert it into an IPLD schema and pass that into the resolver with like as context.
Okay. So we could put a junction point in the system and say, look, we haven't done this now because of time and cost, but what we'd like to do is make an extra level that actually does legitimate IPLD schema conversion and checking using GraphQL.
Yeah, I actually am using something like that in a program I'm writing right now. Like you just define a single walk function and it walks the whole entire GraphQL, like the whole blob of GraphQL declarations and converts them into whatever you want.
Okay, so you'd be saying that I would rewrite the W8 model system using GraphQL queries.
No, I think what we should do is we should just extract right now. I think the common logic that needs to go into the ORM first. Like, I think the dumb version is just a library that like it just provides functions that you want to call inside of these other functions, right? I think the far future goal is to provide like various types of GraphQL wrappers around this. Like, I also don't really want to be married into the GraphQL environment also, right? Like, you know, it's cool that like you could just do a GraphQL query what I really like about like interpulse is there's not a lot of like actual structured declarations you need to make. You could almost do front end only coding, right?
That's the
Like,
goal.
and just know that like there's going to be an infinite amount of, or like an infinitely robust object that automatically has that schema backing it, right?
Yeah. That's the idea. That's the idea.
Yeah.
All right. So
I just don't want to get lost right now. Like I want to have a task to pull out the common functionality in here, and like maybe I'll give a slightly clearer, because I have to go look through a bunch of stuff that I haven't looked at in a while, but a clearer idea of what I mean with the GraphQL.
Right, because just skimming through the docs on GraphQL, I think what you're asking for is that each model class would need to be written and specified using GraphQL schema with resolver functions on each field, and that's where the logic would go. That would allow co-location of the IPLD schemas, the type checker, and the hydration system kind of all together.
But again, like I think you want to hit your compile target first before you start trying to make it compatible with a different schema language.
Yep, I agree with you. Okay, so how do we price this?
I think we need to have a staged idea proposal.
Okay, so idea version 0 is straight up extract.
Yeah. Idea version 1 is probably like, co-locating the schemas and the kind of decorator language and the logic of the class instance all in the same place.
I would suggest that version 1 would be encryption, because that's a whole unknown thing and it may impact the design.
Yeah, no, that's a good idea. When you're thinking encryption, are you thinking just like I've passed a key into this thing and like it just does everything the same way, but just with an extra
like here's a key and here's a hash, inflate,
right?
And it would
grab it and then decrypt it.
Decrypt it, which tells it what to grab next, and then it can walk the graph as it's decrypting it. So you get this completely opaque view when you're looking at it from the outside. You don't know what's connected to what. It's just a whole lot of blobs of data. You would be able to discern some information based on the size of the blobs and the write time of them. Like you could be like, that's definitely a pulse. And I think the state is about 400 kilobytes. But that's all you get. And that's kind of where I was getting at this. Not that it's important right now, but this being able to dynamically shift what gets punched out based on a formula rather than based on the developers specifying it could first of all give us some performance gains, but second of all could give us obfuscation in the encryption, because if you randomize where that junction point or how that junction formula worked, then the blocks that were encrypted would be coming down as all these random sizes and different sizes, and you don't really know what's going on from the outside.
Can you get very far with just size analysis?
A long way.
Oh, okay.
Well, you can tell activity, right? Like you're like, oh, I know that you've been doing this. You're running this chain that only does account balances for this Russian oligarch, and I've seen a lot of activity happening right when the New York Stock Exchange opens each day. So, like that's a lot. There's a lot.
Mm-hmm. Yeah, I always forget about like metadata thinking when it comes to encryption.
Yeah, hooking it all up together can get you quite a way.
Yeah, okay. So then there's value to random sizes. I guess the other thing about random ejection is it would probably force some degree of random intervals as well. Like sometimes you'll have all the data you need and you won't need to go and reinflate more.
Yeah.
And sometimes you won't, and that means that
Yeah.
you'll have like your timing will be randomized a little bit as
Yeah,
well.
yeah. Your timing will be all over the place as well. So that's basically the consideration I wanted to put in there. I'm not sure if it might be very complicated. It might cause debugging to just drive you mental. But I mean, I don't want to be debugging raw byte arrays anyway. I need them hydrated for it to
Right.
mean something to me. And once they're hydrated, do I care if the hydration layer had randomized a bunch of stuff on my behalf? Probably not.
The only problem with randomizing is like I guess like we don't have much room to be random in the blocking process.
Yeah, we do, because you can choose to clump a bunch of things together or stick rigidly to the parts that were intended to be punched out by the developer. Like, we can choose to glob them all together. It
Right.
might be more efficient that way.
But you only have pseudo random functions, right?
Well, the randomizing, it would be the engine's prerogative. So like the validator can draw on an external source of randomness to decide how to
So it's during blocking, so you can avoid
Yeah.
the whole right, but then multiple validators would need to be able to have the same randomness, right?
No, because they're receiving the pulse from the proposer, and the formula by which to rehydrate is contained within that first encrypted block. And so they just walk and check that the formula is correct. It was the original proposer's prerogative to choose random values.
Oh, so the other validators aren't doing forward like block creation, they're just doing backward checking.
Yeah, if you're the proposer, you would get to. Look, this is getting more and more complicated. I think it's a bad idea. I think it's a bad
No,
idea.
it's you know what? It like when you said metadata analysis, like it reminded me instantly of like a lot of things that I've read from the cryptography space, right? Like
Yeah.
it is kind of a nice target to try to hit. I just
Yeah.
think that validators have certain like I guess like purity rules that they need to adhere to. Maybe you probably understand more of them than I do, for sure. Determinism rules, I guess, not
Yeah,
purity.
determinism. You're right that like when you have multiple validator, the randomizing actually inserts a bit of a spanner in the works.
Mm-hmm. Unless it's a seeded pseudo random, right? Like, in which case, like all the entropy has to be passed in at the beginning of the chain, right? Like, you really only get one shot to add entropy to chain plan.
Yeah, so I've got a key in there that's called entropy.
Mm-hmm.
And it's what you use to seed everything with, and each time you call it, it increments it pseudo randomly. Because I've made a system that gives you the same chain IDs every time in testing,
Mm-hmm.
so I need the entropy, because otherwise everything's got the same chain ID.
Does it work? Does that work in the long run? I think
Yep.
it must, right?
Absolutely.
Like a pseudo random is just about uniform probability distribution in the
Yeah, and if you never expose what it is or what its source was,
right,
then you can keep incrementing it and reusing it very cheaply, but also, the recipient of the randomness has no idea what the next thing's going to be.
Where is it stored that nobody can see it?
In the config of the chain. So if you can see the config of the chain, then yeah, you can predict what comes next. But if you're a remote chain, you can't see that.
Right.
You can
So it's an
only
environment variable for a node, basically.
It sort of looks like an environment variable for the isolation context that chain is run in.
Right.
So once we get time, we do things like overwrite math.random within that environment to actually call into the entropy source, get it out, increment it, and then store it in the next block. The dev just thought magically it was math.random, and they're like, haha, but really it was this whole this whole machine kicked in for them.
That's cool. Okay, we're way off pace. Okay, so I think version 1 of encryption is basically just uniform. Like it's all loaded and unloaded the same way. It's just it's encrypted before you do it.
Yeah, that's fine. So you're provided with the root of the pulse.
Mm-hmm.
You run the encryption on it. No, sorry, you provided
leaves in, right?
You got the pulse. You start from the leaves, encrypt each leaf, take the hash of the encrypted block, feed it up.
Oh, the hash has to come after, doesn't it?
Hash. Yeah. That's the thing. The hash has to come after.
Right.
And you cannot be able to look into those blocks and see what their links down are. The block looks like it has no external links. It's just opaque data. Once you have the key and you decrypt it, you can see what the links for you to look up next are, which get the next round of encrypted blocks to be decrypted and walked in that sense. That will give us, with albeit a metadata sensitive signature, it will be properly opaque, like encrypted at rest, and you would not know what was what.
Right. To me, I think that's a pretty good cut line to like switch over to something else at that point, and keep working on stuff that's more valuable to the end application.
Absolutely, yeah. That's what I'm really getting at when I'm like, do we need the annotation language? Because I'm like, we just need this. This thing should be light, fast, quick, and cheap, and it's a way to get a new feature in there, plus get you familiar with the code base, plus get stability in the core, all these things. But really, what I want is you and I need to figure out more direct things to do.
I'd love to use it. Like I'm a very big believer in the idea that context switching is like really the most painful thing in a lot of software projects and like a massive time sink. So I'd like to get some kind of idea of like where the ORM might be headed and whether it's related to userland code while I'm working on this. Yeah. But I think I'll just draft it as another idea then, basically.
Yeah, it's just an iteration on the idea. And I think that you're right. Once it's extracted, that's the time to consider expansion or annotations and all those things. But it'll become clearer at each stage. Plus, at the same time, our utility of it. I mean, I only just started using it in Anger like a few weeks ago because it was finally ready. So, who knows what other uses we've got. We haven't really hit DevLand yet. We've just been sort of taking baby steps. So, there's a lot more to come.
Yeah. I'm keen to get to an actual working application. I really am.
Me too. Okay, so I'll wait for your series of ideas to turn up.
Yeah. You want me to PR those right into the Dreamcatcher site?
Yeah, just drop them in master.
Okay. Oh, not even PR.
Nah, just who else is gonna who you gonna hit?
I like that the request and the idea kind of came out as the same picture, but one is like what it looks like from the outside, and the other is what it
Yeah.
like looks like under an X-ray.
Yeah. So, yeah.
Okay, yeah, that's fine. I'm gonna get right to it. I'm gonna keep working on it
All
right
right, great.
now.
That's awesome. Okay, and then as soon as we can, we'll figure out a price for a packet, and then we'll get that set up, right?
Yeah.
Okay, so
I
you're
think
not
you want to do it with time estimates, like
not really, man. Not really.
no,
Just
you want to invite the
I'm like,
devil
well,
back in.
what?
So, like, I think it's hard to understand what the value of something that's super low level would be, right?
But we're not concerned with the value at all because the
Well,
value is calculated at point of use.
right.
Whereas what we're concerned with is cost.
Right.
Yeah. Now I better run. Sorry.
Yeah.
But yeah, if you get those ideas up and then figure out the cost you need to be an incentive for you to reach that target.
Yeah.
Keeping in mind that the value is still continually paid out to you in the future based on the formula. So yeah.
Yeah. Okay.
All right.
All right. Have a good one. Bye.
Thanks. I'll see you later.